today we'll be discussing about the probability of an event. So if an experiment can result in any one of n different equally likely outcomes, and if exactly the small n of these outcomes correspond to an event A, then the probability of our event A is equal to the small n over the big N, wherein the small n denotes the outcomes which correspond to your event A, and the capital N corresponds to the total different equally likely outcomes. Okay, so for example, say if you are to toss a die, okay, the sample space would be 1, 2, 3, 4, 5, and 6. Since the die has 6 faces and each of the faces correspond to a number, the total sample space is 1, 2, 3, 4, 5, and 6. Okay, or I mean the total sample points should be 1, 2, 3, 4, 5, and 6. Okay, if our event A correspond to the event after we toss a die, the resulting number would be less than 4. Okay, the probability of event A happening would be the small n over the capital N, wherein the small n corresponds to the outcomes for our event A. Okay, what are the possible outcomes for our event A? That would be the numbers less than 4. So what are the numbers less than 4? That would be 1, 2, and 3. So for our small n, that would be 3, and for our capital N, that is the total number of possible outcomes. So since there are 6 possible outcomes, that would be 6. So therefore, the probability of event A is equal to 1/2. Okay, next. The probability of event A is the sum of the weights of all the sample points in A. Therefore, the probability of A should be in between 1 and 0. And the probability of your null set, okay, the probability of a null set is equal to 0. And the probability of your sample space is equal to 1. Okay, sige. So, this means that the maximum probability that we can get is only 1 or 100%. And the least would be 0. Okay, that is what this statement means. And the next one is that the probability of a null set, okay, is 0. Like for example, if you are to toss a coin, so the sample space would be it's either heads or tails. If your event A is the event wherein a jack will appear if you are to toss a coin, therefore the probability of that happening would be 0. Why? Because you can't expect a jack will appear if you are to toss a coin, right? Diba? You can't expect a jack to appear if you are to toss a coin. So therefore, the probability of a null set is equal to 0. And what is a null set? This is the intersection, diba? The intersection between two events. Say if your event is event A and the sample space can also be an event. Okay, these two doesn't have an intersection. These two events doesn't have a common thing between them. So therefore, the probability of that happening would be 0. And lastly, the probability of the sample space is equal to 1. Okay, so if we change our event A, I mean, if we are to use the same sample space for the tossing of a coin, the heads and the tails, if our event A states that it is the event wherein we are to expect a head or a tail that will occur. So what is the probability of our event A? Or since the points of our probability of our A is also equal to our sample points, therefore the probability of our A is equal to 1. And the probability of our sample space is also equal to 1. Okay? Sige, next. And furthermore, if A1, A2, and A3 is a sequence of mutually exclusive events, therefore, the probability of the union of all these events is equal to the probability of A1 plus the probability of A2 plus the probability of A3 up to the probability of AN, if they are mutually exclusive events. Example. So, a statistics class in a statistics class for engineers consists of 25 industrial, 10 mechanical, 10 electrical, and 8 civil engineering students. If a person is randomly selected by the instructor to answer a question, find the probability that the student chosen is A, an industrial engineering major student, and B, a civil engineering or an electrical engineering major student. So, to answer the problem letter A, our first task is to determine what is the total number of possible outcomes. So that would be the total number of students. So that is N. That's our big N. So what is the total number of students? That would be 25 for industrial, 10 for mechanical, 10 for electrical, and 8 for civil engineering. The total of this is equal to 53. And we are asked, for letter A, we are asked to find the probability of choosing an industrial engineering major student. So the probability of choosing an industrial engineering major student is equal to the small n over the big N, where in our small n, okay, is the outcomes which correspond to our event A, or I mean event I, wherein event I is the event of choosing an industrial engineering major student. So what is the probability of choosing an what is the probability of choosing an industrial engineering major student? So that would be, since there are 25 industrial engineering students, that would be 25 over 53. So that is now the probability of selecting an industrial engineering major student. So for letter B naman, okay, we are to find the probability of selecting a civil engineering or an electrical engineering major student. So if we are to write that one, we are to find the probability of selecting a civil engineering student, wherein our event C is the probability of selecting a civil engineering student, and the union of your probability of selecting an electrical engineering student. Okay? So therefore, since they are mutually exclusive, a civil engineering student cannot also be an electrical engineering student. They don't have an intersection between these two events. Therefore, the probability of the intersection between C and E is equal to the probability of C plus the probability of E, wherein the probability of selecting a civil engineering student is equal to, since this is 8, there are 8 civil engineering students, that would be 8 over 53 plus the probability of selecting an electrical engineering. Since there are 10 electrical engineering students, that would be 10 over 53. And our final answer is 18 over 53. Next example. A coin is tossed twice. What is the probability that at least one head occurs? Pause this video right here if you want to try to answer the problem. So let's try to do this in simple ways. So if we are to toss a coin, there are two possible outcomes. That would be head or tails. This is for your first toss. And after your first toss, you are going to toss again since it is tossed twice. So therefore, there could be another two possible outcomes after your first toss. So that would be another head and tails. Head and tails. This is for your second toss. So the sample space would be, for your first toss, you have head, and the second, you have head. For the first toss, you have head, and the second, tails. For the first toss, you have tails, and the second, head. And the third, you have tail and tail. Okay. The question is, what is the probability of getting at least one head, or at least one head occurs? So how many points in our sample space does have a head? So that would be this one, and this one. Therefore, the probability of selecting at least one head should be the outcomes which correspond to your event, that would be 3, divided by the total number of your possible outcomes, that would be 4. So the probability of getting at least one head should be equal to 3/4. Next, a die is loaded in such a way that an even number is twice as likely to occur as an odd number. If E is the event that a number less than 4 occurs on a single toss of a die, find the probability of our event E. Okay. Since in our definition in the previous slide, we said that the probability of our sample space is equal to 1. Okay? In this problem, what is our sample space? Our sample space is equal to 1, 2, 3, 4, 5, and 6 because a die has 6 sides and each of the sides correspond to a number. Therefore, we have numbers 1 to 6. So our sample space should be 1 to 6. And in this statement right here, it says that the probability of our sample space is equal to 1. Therefore, each of these probability, if we add those up, that should be equal to 1. Okay? If this has an x probability, this also has an x probability, this also has an x, this one, and this one, and this one. If we add those up, that should be equal to 1 because the probability of our sample space is equal to 1, right? Alright? And it says here in the problem that the even number is twice as likely to occur as an odd number. So therefore, for our even numbers, we have twice as much probability than our odd number. If our odd number has the probability of an x, therefore, for our even number, that should be 2x. Okay? For our even numbers, that should be 2x. And if the if E is the event that a number less than 4 occurs on a single toss of a die, we are to find the probability of E. Okay, what are the numbers less than 4? So that would be 1, 2, and 3. And what are their probabilities? That would be x, 2x, and x. Okay, so the probability of E, therefore, is equal to x plus 2x plus x. But wait, we need to find the value of x muna. So again, it's we said here in our previous slide that the sum of all probabilities should be equal to 1. So therefore, x plus 2x plus x plus 2x plus x plus 2x, that should be equal to 1. And this one is 1, 2, 1, 2, 1, 2. That would be equal to 9x is equal to 1. So therefore, the value of x is equal to 1 over 9. So substituting to this equation right here, the probability of our event E is equal to, how much is this one? This would be 4x. And our x is 1 over 9. That would be 4 times 1 over 9. That would be 4 over 9. Next, this is the additive rule of probability. If A and B are two events, okay, therefore the probability of the union, okay, in our Venn diagram, diba, we related the union, intersection, and complement using our Venn diagram. Okay, so the additive rule of probability states that the union of event A and B is equal to the probability of A plus the probability of B minus the intersection of the probability of A and B. Okay? Sige. And the next one is if A and B are mutually exclusive, meaning they don't have an intersection. Okay? Wala nira intersection. The probability of the union of A and B should be equal to the probability of A plus the probability of B. Okay, so ganito kasi yan. For our first statement right here, if this is our probability A and this is our probability B, if we try to combine them, if we are to combine them, parang ganito yan. Okay? So this is now our probability of B and this is now our probability of A. Take notice that in the first statement, diba, we are to subtract an intersection between A and B because the probability of the union of A and B is the area of this one, the area of the blue and the area of the red. Okay? We are to subtract iniya nga intersection din hi. Okay, kumbaga there is an area that is at the back of the probability of B. So we need to subtract that one in order for us to determine what is the total value of the area. This blue area and this red area right here. We need to subtract at nga na overlap. Okay, and if they are mutually exclusive, then i-add mo lang here. A plus B, waray mo near intersection. The probability of A plus the probability of B. That is your probability of the union of A and B. We can extend pa this idea further if we are to use three probabilities. So take a look at this one. If we have events A, this is our A, say if this is our A, our B, and our C. If we are to use the union of three probabilities with intersection, parang ganito yan. Okay? So, therefore, the probability is the area. The probability of the union of A, B, and C is the total area shown. Minus, ato nga natatabunan na area, so as this one and this one. So, therefore, the probability of the union of A, B, and C provided that A, B, and C has an intersection. Okay? Kaya kung mutually exclusive edi probability of A plus probability of B plus probability of C la ito waray na ini ang extension. If they have an intersection, therefore the probability of the union of A, B, and C should be equal to the probability of A plus B plus C minus the probability of the intersection of A and B minus the probability of the intersection of A and C minus the probability of the intersection of B and C plus the probability of the intersection of A, B, and C. Yun. Ito, example. John is going to graduate from an industrial engineering department in a university by the end of the semester. After being interviewed at two companies he likes, he assesses that his probability of getting an offer from a company A is 0.8. Wow. And his probability of getting an offer from another company B is 0.6. If he believes that the probability that he will get offers from both companies, which is equivalent to 0.5, what is the probability that he will get at least one offer from these two companies? Okay, pause this video right here if you want to try solving the problem. Okay, sige, if we are to solve this problem, this is just the union of both event A and B. So therefore, the probability of the union of A and B, is equal to the probability of A plus the probability of B minus the probability of the intersection between A and B. Kumbaga, if we are to draw this one, so the probability of getting an offer from company A is 0.8. This is company A. Company B is 0.6. And the probability that he will get offer from both companies should be the intersection between these two. Okay? So, therefore, parang ganyan yan. You have at this one 0.8 and this one 0.6. And the intersection should be 0.5. So, the 0.8 is the whole of this area. And the 0.6 is the whole of this area. Okay, if we are to find this area right here, inihiyang area, plus inihiyang area din that would be, we need to find this value of the area right here first. So that would be 0.8 minus 0.5. That would be 0.3. Okay? And we also need to find the value of the area right here. So that would be 0.6 minus 0.5. That would be 0.1. So therefore, ano yung gagawin natin? Ganito na lang. We need to add na lang this probability of event B plus 0.3. Okay, that would be 0.6 plus 0.3 if we're using a Venn diagram. That would be 0.9. So if we try to use the formula right here, that would be what is the probability of A? That would be 0.8 plus the probability of B, that is 0.6, minus the probability of the intersection of A and B, that would be 0.5. So solving this one, that would be 0.8 plus 0.6 minus 0.5. That is again the same lagi hapon ito, 0.9. Next example for additive rule of probability. What is the probability of getting a total of 7 or 11 when a pair of fair dice is tossed? A pair of fair dice is tossed. Okay, so in order for us to solve this problem, we need to find the combination, or we need to find the combination of the two dice wherein we can get 7 or 11. So that would be, for the first die, we can have 1, and the second, we can have, this is for the 7, ha? This is for the 7. So for the first die, we can have 1 and 6. Then we can have 2, 4, 2 and 5. We can have 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. This is the ways in which we can get 7. And for the ways naman, in order for us we can get 11, that would be 5 and 6, and 6 and 1. Okay? The question is, what's the probability of getting either of 7 or 11 from a pair of dice? So you need to find the total number of possible outcomes. Okay, that would be from our multiplication rule, di ba nasa rin kita? Okay, that n should be equal to the first dice has a 6 sides, so that would be 6 times the second die has also 6 sides, so that would be 6 also. So the total number of possible outcomes should be 36. So that would be 6 times 6. So we can have two probabilities in here. We can get the probability of getting 7, that should be equal to n over the small n over the capital N, plus the probability of getting 11, that would be the small n over the capital N. So how many possible ways, or what are the possible outcomes in which we can get 7? So that would be 1, 2, 3, 4, 5, 6. That would be 6 over 36. How many outcomes can we correspond in getting an 11? So that would be 1, 2. So 2 over 36. If we add these two, okay, because this is a union, the probability of getting 7 or 11, this is actually the addition, the sum of the probability of 7 plus the probability of 11, getting 11. So that would be 6 over 36 plus 2 over 36. That would be 8 over 36. Can we write this one in simpler form? We can have 2 over 9. We can have 2 over 9. That's now our answer. Next, in a bag, there are 8 green cubes, 9 green spheres, 5 yellow cubes, 7 yellow spheres. Next, in a bag, there are 8 green cubes, 9 green spheres, 5 yellow cubes, and 7 yellow spheres. What is the probability of drawing a yellow or a cube? Okay, this is similar to the example number 2, but there's a little twist lang in here, because we have two different properties for each cube. We have its shape and its color, or the color and its shape. So we can have actually a yellow cube and a yellow sphere. So the question is, what is the probability of drawing a yellow or a cube? So similar in the example number 2, this is actually the probability of the union between yellow and cube. Okay, from our formula for the additive rule of probability, we can have this one as the probability of y plus the probability of c minus the probability of the intersection between yellow and the cube. Okay, what's the probability of getting yellow? So, ano natin mga what are our values? We have 8 green cubes, 9 green spheres, 5 yellow cubes, and 7 yellow spheres. So, what's the probability of getting a yellow? You can have this one and this one. So, that would be 7 plus 5. That would be 12, right? 12 over the total number of cubes. The total number of items in the bag. It would be 7 plus 8 plus 9 plus 5. That would be, our big N is 29. So, we have how many cubes that is yellow. So, that would be 5 and 7. That would be 12 over 29. Plus the probability of, and we also have the probability of getting a cube. What's the probability of getting a cube? That would be, saan yung cube? Ito, cube. Green cube and yellow cube. So that would be 8 plus 5. That should be 13 over total number of items in the bag, 29. And lastly, we have the probability of the intersection of yellow and cube. So that would be not on yellow cube. What is our yellow cube? That would be 5 over 29. Okay, substituting these values to this formula, we have the probability of the union of yellow and cube should be equal to the probability of getting yellow plus the probability of getting a cube minus the probability of getting yellow cube. 5 over 29. The probability of getting yellow or a cube is equal to 20 over 29. Okay? To, another example. If the probabilities are respectively 0.9, 0.15, 0.21, and 0.23, that a person purchasing a new automobile will choose color green, white, red, and blue. What is the probability that a given buyer will purchase a new automobile that comes in one of those colors? Since these colors are distinct, at least for this problem, meaning the green cannot be white, and also the green cannot be red, and so on and so forth. Okay, this means that the probability of the union between the green, white, red, and blue is equal to the probability of getting a green car plus the probability of getting a white car plus the probability of getting a red car plus the probability of getting a blue car. So therefore, you have to add all those probabilities lang. Probability of getting a green car, that would be 0.09 plus 0.15 for white plus 0.21 for the red plus 0.23 for the blue. So the probability of the union between green, white, red, and blue is equal to 0.68. Next topic will be on complementary events. So if A and A prime are complementary events, therefore the probability of A plus the probability of the complement of A is equal to 1. Example. If the probability of selecting a yellow marble from a bag full of marbles is 20%, what is the probability of selecting a marble that is not yellow? So this means that the probability of selecting a yellow marble is equal to 20% or 0.20. Okay? Kung it probability nga makakakuha kan yellow is 0.2, ano man it probability nga makakakuha ka hindi yellow or yellow complement. Di, i-minus ko inihawan, I'll just subtract this to 1. Because the probability of getting a yellow plus the probability of getting a not yellow marble is equal to 1. If we have this value right here being equal to 0.2 plus the probability of getting a not yellow, okay, transposing this one to the other side of the equation, I have 1 minus 0.2. Or the probability of getting a marble that is not yellow is equal to 0.8. Or, kumbaga, common sense na la. You can just use our common sense. The probability of selecting a yellow marble is 0.2. The probability of selecting a marble that is not yellow, edi, i-minus ko ito 100, kumbaga. Or i-minus ko 1, so that would be 0.8. More of a common sense related complementary events. Example. Yun, haba ng example. Suppose the manufacturer's specification for the length of a certain type of computer cable are 2000 plus minus 10 millimeters. In this industry, it is known that small cable is just as likely to be defective, meaning it does not meet our specifications, as large cable, meaning the probability of getting a large and a small cable are the same. So that is the probability of randomly producing a cable with length exceeding 2010 millimeters is equal to the probability of producing a cable that is smaller than 1990 mm. The probability that the production procedure meets the specification is known to be 0.99. The question is, what is the probability that a cable selected randomly is too large? And lastly, what is the probability that a randomly selected cable is larger than 1990 millimeter? Pause this video right here if you want to answer the problem. Okay, let's try to solve the problem. Okay. It says here in the problem that the probability that the production procedure will meet the specification is 0.99 or 99%. So the probability of getting the exact specification, which is 2000 mm, is 0.99 or 99%. Mataas nga duro. Okay, therefore, the probability of getting the not exact, di ba? Kung baga ganito, the probability of getting an exact, okay, computer cable is 0.99. So therefore, it probability nga makakakuha kan diri exact or the complement of E is 0.01. Right? And also, it stated here in the problem that it is known that small cable is just as likely to be defective as large cable, meaning the probability of getting a large cable and the probability of getting a small cable is just the same. So the probability of getting a large cable and the probability of getting a small cable is just the same. And we know that the probability of not getting the exact value is 0.01. Since there are two limits in here, you just need to divide this one by 2. So that would be 0.005. Meaning, there is a 0.5% that we can get a cable that is large, and also a 0.5% that we can get a cable that is small. So the question for letter A is what is the probability that a cable is the cable selected randomly is too large. So ito na yun. The probability of selecting a cable that is too large is equal to 0.05, or that is 0.5%. And for letter B naman, the question is, what is the probability that a randomly selected cable is larger than 1990 millimeters? Okay, sige. If we are to plot this one in a number line, parang ganito yan. So you have in here 2000, and you have 2010 and 1990. So again, we all know that this industry has been manufacturing cable that has a plus and minus 10 mm nga difference. So at this point, an aton probability of getting these values is 0.99. And beyond this number line, and probability of getting a large cable is 0.05, and the probability of getting a small cable is also 0.05. Again, because it's it says here in the problem that the small cable is just as likely to be defective as the large cable. So, meaning again, the probability of getting a small and a large cable is equal. Okay? So, the question for letter B is we are asked to find the probability that a randomly selected cable is larger than 1990 millimeter. So, we need to find the probability of our cable from 1990 onwards. So, what's that probability? So, from here to here, that is 0.99. And from here onwards, that is 0.05. So, therefore, the probability of getting 1990 cable, the probability of producing a cable that is greater than 1990 is equal to the probability of getting an exact value. This is this line right here, plus the probability of getting a large value. So that would be 0.99 plus 0.05. Therefore, the probability of getting a cable which is greater than 1990 is 0.995. Or you can just use the complementary event. Okay, you know that the probability of selecting a small cable is 0.05. Right? So, the probability of getting a cable that is not small, or the complement of S, should be equal to 1 minus this value, 0.005. So, that would be the probability of getting a cable that is not small is 0.995. Pareho lettera. Okay? Next, we have conditional probability. Ito yan. The conditional probability of A given B, okay, is denoted as this one. The probability of A given B is defined by this formula. The probability of the intersection between A and B divided by the probability of B. If this is your event A and this is your event B, the conditional probability or the probability of A given B, meaning maaram kanahan B, ano man yan at probability nga may hitabo it A kung maaram kanahan B. Parang ganon. So, the probability of A given B, kumbaga, ang B ni mo is fact na ito. Tuod na ito, yeah. It's a fact. So, therefore, what's the probability of getting A given B? Ganito yun. So, the probability of getting the probability of A given B is the ratio between the intersection of A and B divided by the total of B, the total area of B. Again, the probability of A given B is the ratio between the probability of the intersection between A and B divided by your event, the probability of event B. Okay? Question. The probability that a regularly scheduled flight departs on time is 0.83. The probability that it arrives on time is 0.82. The probability that it departs and arrives on time is equal to 0.78. We are to find the probability that a plane is letter A arrives on time given that it departed on time. Letter B, departed on time given that it has arrived on time. Letter C, arrives on time given that it did not depart on time. And letter D, departs on time given that it did not arrives on time. Okay? So, ganito yun. So, let's try to solve the problem. Sige. So, the probability of, ito na lang, the probability of D or the flight departs on time is 0.83. And the probability that it arrives on time is 0.82. And the probability that it departs and arrives on time is equal to 0.78. The question is, find the probability that it arrives on time given that it departed on time. Okay? So, the probability that it arrives on time given that it departed on time. So, this is using our conditional probability. That would be the probability of A, the probability of the intersection of A and D all over the probability of D. So, that would be this one, the intersection 0.78 divided by the probability of D, the 0.83. So, the answer is the answer is 0.94, meaning this is the probability that it will arrive on time given that it departed on time. Similarly, if we are to find the probability that a plane departed on time, okay, that a plane departs on time given that it has arrived on time. So, this is for letter A. For letter B naman, for letter B, we have to find the probability that it departs on time given that it has arrived on time. So, the intersection between D and A, the intersection between D and A and D is the same. Okay? Kumbaga, this one, like for example, this one, the intersection between A and B and A is just the same. Divided by the probability of A. The intersection of D and A is 0.78. Divided by the probability of A is 0.83. Oh no. The probability of A is 0.82 pala, sorry. So that would be the probability of D given A is equal to how much? 0.95. For letter C naman, how will we solve for letter C? It arrives on time given that it did not depart on time. Okay, let's write lang muna the complementary events for event D and event A. So, what is the complementary event of event D? What is the complementary of event D? That would mean that if event D is a plane which arrive on time, for the event D prime, it means that it did not arrive on time. Okay, kung an imo event D is 0.83, it arrives on time. An event D, it did not arrive on time. So that would be 1 minus 0.83. 1 minus 0.83, and that would be equal to how much? That's 0.17. And for the complement of event A, that would be 1 minus 0.82. That would be 0.18. So for letter C, so in answering for letter C, okay, we have actually we are asked to find the probability that it arrives on time given that it did not depart on time. So that's why we did this one. We tried to find what is the probability, okay, of the complement. Okay, so the probability of D, meaning the probability of the event that it departs on time, is 0.83. So if it does not depart on time, 1 minus 0.83. So that's why we need the complement of D. Okay, and so it's the same for the complement of A. The probability of the complement of A is 1 minus 0.82. So we have 0.17 and 0.18. So yun na, in answering for letter C, okay, so we are to find the probability that it arrives on time, okay, that it arrives on time given that it did not depart on time, okay, it did not depart on time. So okay, so using the formula, okay, we've mentioned earlier, Okay, this is the same. This is just similar. So meaning this will be equal to the probability of the intersection between A and D prime divided by the probability of your D prime. So that's why we determined first the probability of D prime in here. Okay, so yun. So kumbaga, what is the probability that it will arrive on time given that it did not depart on time? Yun. Okay. Sige. How are we going to do this one? We need to find this one, this value. What is the probability of the intersection between A and D prime? Okay. Remember our Venn diagram. So, okay. If we have a Venn diagram that looks like this, and if this is our event A and this is our event D, or the probability of the plane that it arrives on time is 0.82. And the probability that it will depart on time, that is 0.83. And the probability, of the intersection between D and A is 0.78. Okay, so the whole of A is 0.82 and the whole of D is 0.83. Now we are to find the intersection between A and D prime. So what is the definition of our complement? So anything that is not in D. Anything that is not in D. So meaning, in here din yung area. This area right here. Excluding the intersection between A and D. Okay? So this this area right here, the area of A, excluding the intersection between A and D. So therefore, that would be equal to the probability of A minus the probability of the intersection of A and D. Okay? All over the probability of your D prime. Okay, what is the probability of A? So that is 0.82. And subtract that one to the intersection, that is 0.78. Divided by the probability of your D prime, which we computed earlier, that is 0.17. We have a value of 0.2352, or that is equal to 23.52%. Okay, so that is the probability that it will arrive on time given that it did not depart on time. Okay, so yun. Say, kumbaga, nasakay kayo ng aeroplano, tapos, baga na-late aniyo kuan, na-late aniyo flight. So, mako-compute nimo kung ano probability nga makaka-arrive ka nga dot imo destination given niya late aniyo departure. Okay, ang ganda, di ba? Okay. So for letter D naman, so this is just similar to what we did earlier, kanina. So we are to find the probability that it will depart on time given that it did not arrive on time, or the A complement. This means that this is equal to the probability of the intersection between D and A prime all over the probability of A prime, or the A complement. So that's why we solved it earlier. So in order for us to determine the probability between the intersection between D and A prime, let's try to look at our Venn diagram again. If these are our two events, this is event D and this is our event A, and the intersection between them is the intersection of A and D. So in here we need to calculate the probability of the intersection between D and A prime. So what is the definition of our A prime? So lahat ng wala sa A, so that is our A prime, or A complement. So that would be event D minus the intersection between A and D. Okay, that would be event D, the probability of event D less the probability of the intersection between A and D all over the probability of A. So the probability of D is given, that is 0.83 less, okay, 0.78 for the intersection divided by the probability of A, that is 0.82, and that is equal to 0.06097, or that's equal to 6.09%. Okay, so this is the probability that you will depart on time given that the plane will not arrive on time. So, kumbaga, ito yung probability na makakaalis kayo on time given that hindi dumating yung plane nyo on time. Next is the product rule. So, yun. The definition of your product rule is this one. If the experiment, okay, if an experiment, okay, the definition of your product rule is this one. If in an experiment, the events A and B can both occur, so then the intersection of the probability of the intersection between A and B is equal to the probability of A multiplied by the probability of B given A. So, di ba we have the formula kanina that if we are to find the probability of B given A, that's equal to the probability of the intersection between A and B all over the probability of B. Okay? So yun, if you try to do cross multiplication, we have the probability of the intersection between A and B. That is equal to the probability of B, okay, multiplied by the probability of B given A. So this is just basically the definition of your product rules. Okay? Kung kanina the conditional probability is the ratio, okay, between the intersection and an event. Yan na naman, the intersection is equal to the probability of an event multiplied by the probability of an event given another event. Okay, so yun. If in an experiment, the events A1, A2, and A to the n, A to the nth or A kth, okay, can occur, then the probability of the intersection for those events will be, the probability of the intersection of those events is equal to this one. Probability of A multiplied by the probability of A2 given A1 multiplied by the probability of A3 given the intersection of A1 and A2, so on and so forth. And if they are independent naman, the intersection of those events is just the probability of each of those events lang. Okay, so for the probability of the intersection of A1 up to A kth is just equal to the probability of each of the events up to A kth. Okay, example. Okay, so suppose that we have a fuse box containing 20 fuses, and of which 5 are defective. And if 2 fuses are selected at random and removed from the box in succession without replacing the first, what is the probability that both fuses are defective? Okay, so if we are to solve this problem, so say if we have a box, we have a fuse box and we have 20 fuses right here, that is 20 right there, and 5 of those are defective. Okay, we are to remove 2 in succession, meaning magkasunod, without replacing, meaning hindi natin ibabalik. Okay, hindi natin ibabalik or hindi natin dadagdagan yung nasa box. Okay, and we are asked to find the probability, okay, that both fuses are defective. Baga, in your first draw, defective, and the second draw is defective. So yun. So first, we need to find, this is a product rule type of problem because the problem is, kumbaga the nature of the problem involves drawing something in succession. Okay, this falls under the product rule. Parang ganun. This is how I remember this one. Kasi medyo tricky in how you analyze these problems. So, if the problem involves drawing something in succession, so I think that's that falls under the product rule. But this is my this is just my technique. I may be wrong. Okay, so if we are to solve this problem, okay, we know the number of defective fuse. So that is 5 out of 20. So the probability of drawing a defective fuse, okay, in the first draw, because we have 2 fuses to be drawn in succession. In the first draw, okay, we know that there are 5 defective fuses in 20 boxes. So therefore, so the probability of drawing defective fuse in the first draw is equal to 5 over 20, because it's just because there are 5 defective and there are 20 boxes in 20 fuses in total. So therefore, the probability of drawing a defective fuse in your first draw is equal to 5 over 20. Okay? And the probability of drawing a defective fuse in the second draw, given that you've drawn a defective fuse in the first draw, okay, that is equal to what? Remember, kumuha ka na hinusa, ha? Remember that you tried, you've already drawn a defective fuse from a box of 20 fuses. So if you've already drawn a fuse, the total number of fuse in the box will be lessened. Okay? If you've already drawn one, therefore the total number of fuse will be 19. And since you've drawn a defective fuse in your first draw, meaning the number of defective fuse in a box was also lessened. So from 5 magiging 4 na laya. So therefore, the probability of drawing both defective fuses in a box is equal to this one. The probability of your D1 multiplied by the probability of your D2 given D1. Okay, that is equal to 5 over 20 multiplied by 4 over 19. And that is equal to what? This is equal to 1 over 19. This will be much clearer if we try to draw a tree diagram. Okay, remember how we did our tree diagram, di ba? In our heads and tails, we try to name all of the possible outcomes. So in there you can also draw a tree diagram. Okay, from the start, you have 2 choices. Either you can draw a defective and a non-defective. Okay, in your first draw, say you've drawn a defective fuse, so that the probability of that is 5 over 20. And the probability of drawing a not defective fuse, that would be 15 over 20. Okay, and after you've drawn a fuse, mabunot ka na luwat, di ba? And again, you either have 2 choices. Pwede defective, pwede gyapon non-defective. Pwede defective, pwede non-defective. Okay? So the probability of let's just try to put subscript para diri ka malipat. Okay? So the probability of getting a defective fuse, okay, after you've drawn a defective fuse, syempre naibanan naman, the number of fuses have been lessened and the number of defective fuses have been lessened. So the probability of this one is equal to 4 over 19. And for the ND naman, so that would be 15 over 19. Okay? So for this one naman, haubos. So that would be, since we've drawn a not defective at first, okay, so naibana na natin non-defective. If we try to find the defective in the second draw, and hindi man na naibanan, so 5 over 19 lagi hapon. D2 is equal, the probability of D2 is equal to 5 over 19. And if it is ND for the second time, okay, that will be equal to, edi kung 15, edi 14 na la, 14 over 19. Kaya naiba na naman ino sa in the first draw. So therefore, the probability of your the intersection of D1 and D2 is just inilara. Just multiply this one, ini and ini. So that will be 5 over 20 multiplied by 4 over 19. It's just basically the same. So yun, if we try to use the your tree diagram, you can also find the probability that the fuses drawn are both non-defective. So the probability of ND1, the probability of the intersection of ND1 and ND2 is just equal to this one. 15 over 20 multiplied by 14 over 19. Okay, and if you are to find gihapon the probability of drawing a non-defective and a defective, so duha may dani mo defective an siya, non-defective an ikaduha, or non-defective an siya, defective an ikaduha. So yun, mas detailed if you try to use the tree diagram for product rule. Mas maintindihan niyo. Okay? Sige. So for the product rule, another example. Ito. So a bag, one bag contains 4 white balls and 3 black balls. So a second bag contains 3 white balls and 5 black balls. If one ball is drawn from the first bag and placed unseen in the second bag, ito, hulbot-hulbot, what is the probability that a ball now drawn from a second bag is black? Yun. What is now the probability that the ball now drawn from the second bag is black? So, kumbaga, duduhat imo, you have 2 scenarios in here. Di ba? This is similar to the earlier problem wherein if we try to find the probability of getting both defective and non-defective, di ba duduhan to naton kuan? Duduhan to naton baga path. So we have defective at first, tas non-defective an ikaduha, and the second is non-defective and first, tas defective and first and non-defective an ikaduha. So it's similar to this problem right here. We asked to find what is the probability that a ball drawn in the second bag is black. So pwede, this has 2 scenario wherein for the first scenario will be you can draw a white ball from the first bag and put it in the second bag. Now you can draw a black ball. Or you can draw a black ball in the first bag and draw a black ball in the second bag. So you have 2 scenarios in here. You are to find the probability of drawing a white ball in the first bag and drawing white ball in the first bag and drawing a black ball in the second bag. Or meaning we are to find this another scenario. We are to add this another scenario. Meaning we are to find these 2 scenarios plus the probability of drawing a black ball in the first draw. Okay, and the black ball in the second draw. So yun. Okay, if we have the if you have the conditional probability formula, that is the probability of B given A is equal to the ratio between the intersection, the probability of A and B, or B and A, all over the probability of A. So it's just similar lang to this one. Okay? Sige. So yun, if we have this one, so we need to find the probability. The probability of drawing a black ball in the second draw given that nakabunot kain white ball in the first draw. Okay? Multiplied by the probability of drawing a. Okay ha? This is the, if you try to notice, Okay, this one is the denominator. So, kung ano yun niya, dapat mo gyapon ni mo probability. So, that would be multiplied by the probability of drawing a white ball in the first draw. Okay, plus the probability of drawing a black ball in the second draw given that you've drawn a black ball in the first draw. Multiplied by drawing the probability of drawing a black ball in the first draw. Okay, we have two bags. Okay, we have white. Okay, upat niya white and 3 nga black. 1, 2, 3. And the other bag contains 3 white and 5 blacks. Okay. So, ito, in the first, for this one, for this conditional probability, the probability of drawing black in the second draw, given that you've drawn white in the first draw. Meaning, we've drawn white in here. Tapos, we transferred it to the other bag. Okay? That is the statement right here. What is the probability of drawing a black ball in the second bag? Okay, given that we've drawn a white ball in the first bag. Okay, kumbaga we've transferred the one white ball from the first bag into the second bag. Ano naman probability of drawing a black ball? Ito yan So that would be, kung tuluan imo white din nadugangan ni Nusa. So that would be 5 black balls divided by the total number of balls. So that would be 5/9. Multiplied by the probability of drawing a white ball in the first bag. So, ilan yung white sa first bag? Okay? Before ka pa mag-transfer This is before you transferred. So, before you transfer, that would be 4 over, because there are 4 white balls over the total number of balls, which is 7. So, that would be 4/7 plus. Okay? Let's try to erase this one para diri kita malipat. Unahin natin dito muna para hindi tayo malipat. Hindi tayo mawala. Hindi tayo malito. Okay, the probability of drawing a black ball in the first bag. So that would be tuluman lera, so 3/7 multiplied by the probability of drawing a black ball in the second bag given that you've drawn a black ball in the first bag. So we are to transfer one black ball in here, transferred to the other bag. So now, what is now the probability of drawing a black ball in the second bag? So, nadagdagan ng isa yung black ball mo. So, naging 6 na sila. So, that would be 6/9. Na 6 na black, total number of balls in the second bag is 9. 5 plus 4, that is 9. Okay? So, that would be equal to how much? That would be equal to 38/63. Okay? Basta drawn in succession. Basta if it involves problem drawn in succession. So, yun yung technique ko. So, I try to solve this problem as a product rule type of problem. Okay? Next example. Ito. So, 3 cards are drawn in succession. Okay, meaning sunod-sunod from an ordinary deck of playing cards. Find the probability that the event A1, A2, find the probability of the intersection of the event A1, A2, and A3 occurs, where A1 is the event that the first card, that the first card is a red ace. Okay, kung mahilig ka mo baraha. So, first card is the red ace. The second card is a event wherein the second card is a 10 or a jack. And A3 is the event that is the third card, which is greater than 3 but less than 7. What are the numbers greater than 3 and less than 7? That will be 4, 5, and 6. And you have 4 types of cards. You have red diamond, red heart, black spade, black clover. Okay, kumbaga, if my memory serves me right. Okay, so yun. So, you just need to multiply lang. Uh, you just need to find, okay, each of those probabilities. Okay? For the probability of drawing A1, okay, that would be equal to what? What is the event? What is event A1? That is a red ace. Ilan yung aces mo sa ano? Sa from an ordinary deck of playing card. Ilan yung aces mo? You have 4 aces. You have 2 red and 2 black. Red being the diamond and the heart. So that would be 2 over 52. I mean, it's either an ace na heart or an ace na diamonds. Okay? So, next, what is the probability of drawing A2 given A1? What's the probability of drawing A2 given A1? Meaning, umiban ka na yun sa, you've removed a card from your first draw. So, meaning the total number of your card will be lessened by 1. So, that would be 51 na lang. Naibanan na sa. Okay? So, the probability of drawing A2 given that A1 had occurred. Okay, what is the event A2? Is the second card, that is 10 or a jack. How many tens in the in a deck of playing card? That would be 4 tens. And you also have a 4 jacks. So, apat na 10, apat na jack. So, that would be 8. So, you have 8 over 51. Next, if we are to find the probability of getting the third card or A3, given that you've already drawn 2 cards, so the intersection of A1 and A2, so that would be equal to, meaning naibanan ka ng 2 cards from your first draw. So that would be the total number of cards will be lessened to 50. Okay? And wherein your event, A3, is the event wherein the card is greater than 3 but less than 7. So again, what are those numbers? That would be 4, 5, and 6. And each of those number has 4 different types. Okay, so therefore that would be 4 times 3. So that would be 12 over 50. Now, if we are to find the probability of drawing, okay, 3 cards in succession, and each of those and each of those events represents A1, A2, and A3. So that would be the intersection of A1, A2, and A3. That would be equal to, you just multiply those 3. 2 over 52 multiplied by 8 over 51, and 12 over 50. And that is equal to 8 over 5525. So that is the probability of that event happening. If you draw 3 cards in succession and each of the events, in each of the letters represent a different event. Okay? Sige. If we try to use naman your tree diagram, so yun, say from the start. Okay? So for your first draw, you can have either black or white in the first bag. So first draw in the first bag. So the probability of getting black in the first draw, that would be a 3 over 7, and getting white on the first draw, that would be 4 over 7. So after another draw, okay, in the second bag, you can either draw a black or draw a white. So the probability of drawing black on the second draw, given that you've drawn black in the first draw, so that would be 6 over 9. Tama, 6 over 9. And for the white naman, that would be 3 over 9. 3 over 9. So you can have either black or white. So if you've drawn white naman from the first draw, so that would be the probability of drawing black in the second row given that you've drawn white in the first draw. That would be 5 over 9. And if you've drawn white, that would be 4 over 9. So if you are to find the probability of drawing a black ball from the second draw, so you have two paths that needs to be considered. So this path in here, the probability of getting black first draw, black second draw, or white first draw and black second draw. So that would be 3 over 7 multiplied by 6 over 9 plus 4 over 7 multiplied by 5 over 9. So you'll still arrive at the same answer. Okay? Nuggets, chicken nuggets. Next is the Bayes theorem. Okay, so for our conditional probability, we say that the probability of A given B is the ratio between the intersection of A and B and the probability of B. Okay? Or, baliktaron natin, if we are to find the probability of B given A, it's just the ratio of the intersection of A and B all over the probability of A. Okay, and as I've said earlier gihapon, that the intersection between A and B is the same. Diba? The intersection between A and B is the same. So therefore, the probability of the intersection of A and B should also be equal. Okay? So therefore, if you try to do cross multiplication, okay, the probability of A given B times the probability of B is just equal to the probability of B given A multiplied by the probability of A. Okay? Dividing both sides by the probability of B, okay, you'll have the probability of A given B is equal to the probability of B given A multiplied by the probability of A divided by the probability of B. So, yun na yung Bayes theorem mo. Sige. Example. So, suppose two dice are thrown. Die X has sides of 1, 2, 3, 4, 5, 6. And die Y has sides of 4, 5, 6, 7, and 8. We are to determine the probability of getting a value of X given that die Y is thrown using Bayes theorem. So if we try to solve this problem using conditional probability, that would be very easy. We are to find lang the probability of getting X given that the Y has been thrown. Okay, so if you try to use the conditional probability, that would mean that this is just the ratio between the intersection. Okay, this is just the ratio between the probability of the intersection of X and Y divided by the probability of your Y. Okay, and how do you do that? You need to find the total sample points for events X and Y. So the total sample points will be 1, 2, 3, 4, 5, 6. Okay, pareho may 6. Tapos continue 7, 8, and 9. Okay, so the probability of X given Y, that would be equal to the intersection of X, the probability of the intersection of X and Y divided by the probability of Y. What's the probability of the intersection of X and Y? Ano yung pinagkakapareho ng X and Y? That would be 4, 5, and 6. So that would be equal to the probability of the intersection of X and Y is equal to 3 over 9. And the probability of Y, that would be how many points in events Y? That would be 6. So 6 over 9. So dividing both sides, dividing these two values, you'll have 3 over 6 or 1/2. Okay, that's 3 over 9 divided by 6 over 9. 9 cancels out. So magiging 3 over 6 na la. So therefore, the probability of X given Y is equal to 3 over 6 or 1/2. But if you try to use, okay, if you try to use the Bayes theorem, it would look something like this. If we are to find the probability of X given Y using Bayes theorem, that would be equal to the inverse conditional probability for this one. So, okay. So, if this is the probability of x given y, so that would be the probability of y given x multiplied by the probability of x divided by the probability of your y. So wherein the probability of y given x, again, if we try to go back to our Venn diagram, so if this is 1 2 3, this is where 4 5 6 resides, because this is the intersection. 4 5 and 6, 7 8 and 9. The probability of y given x, that would be the ratio between the intersection of y and x, okay, divided by x. If this is x and this is y, so that would be, okay, the ratio of this one over probability of x. So that would be 3 over 6 multiplied by the probability of x. Okay, ilan yung points mo sa x? That would be 6 and the total is 9. Okay, all over the probability of y, that would be 6 over 9 gihapon. Okay, because they are both the same 6. I mean, they both have same 6 sample points. So 6 over 9 cancels out. You'll be left with 3 over 6. Therefore, the probability of x given y using the Bayes theorem is also equal to 1/2. Okay. Okay, that's the easy way of doing Bayes theorem. Okay, next example. Ito. This is more of a recent yung mga istoryahon, because this involves swab test in COVID. Okay, so suppose a particular study showed that 5% of people will likely to get COVID at some point of their lives. A person with COVID has a 98% chance of being positive in a swab test. A person without COVID naman has a 5% chance of getting a false positive swab result. Okay? And the question is, what is the probability that a person has COVID given that he had a positive swab test results? In this particular problem, it says here that not all of the positive swab test results means that the person has actually COVID. Because it says here that there is a 5% chance of getting a false positive. Meaning, you can have a positive test result even if you don't have COVID. The question was, what is the probability? What is the probability that a person has COVID given that he had a positive swab test result? Okay? Pero agudit porsyento, ilan ba talaga yung percentage na meron kang COVID given na nag-positive ka sa swab test results mo? Okay, so let's review the given values. The probability of getting COVID, okay, based on this study, is equal to 5%. Okay? That is 0.05. Try to convert that to decimal. So that would be 0.05. So the probability of if the probability of getting COVID is 0.05, therefore the probability of not getting COVID or being COVID-free is equal to 0.95 from our complementary events. Meaning, the probability of being COVID-free is 95%. Okay, the probability of getting a positive test result given that you already have COVID is equal to 98%, or that is 0.98. And a person who is actually COVID-free has a 5% chance of being positive. So that is the probability of getting a positive swab test results given that you don't have COVID or you are COVID-free. So that is equal to 0.05. And the question was the probability of having COVID given that you've already been tested positive in your swab result. So using our Bayes theorem for the solution, using our Bayes theorem, the probability of having COVID given you have a positive swab test result is equal to the probability of the reverse conditional probability for this one, the probability of getting a positive test result given that you have COVID multiplied by the probability of getting COVID all over the probability of getting a positive swab test result. Okay? Ano yung values na meron tayo? We have this value. Okay? We have this value. We have the probability of getting a positive swab test result given that you already have COVID, and we already know the probability of getting COVID. So that is the probability of C. Okay? And we only lack this value. Ito na lang yung kulang natin. Okay? So for this one, again, we're gonna use yung our trusted na tree diagram. Okay? So ito na yun. Our trusted tree diagram. So you can either have COVID or COVID-free. So the probability of getting COVID is 0.05. And the probability of being COVID-free is 0.95. Okay? And if swab test ka, okay, the probability of getting a positive test result given that you already have COVID is what? 0.98. Okay? And what is the probability of getting negative given that you already had COVID? So kung 98 ni, so therefore this should be 0.02. Okay? And if you don't have COVID naman, what are the chances that you'll get a positive test results given that you don't have a COVID? So meaning this is the false positive. So this is 0.05. And lastly, the probability of getting a negative test result given that you are COVID-free. So if this is 0.05, what's left is 0.95 using our complementary probability. Okay, so again, we have two paths in here. Okay, so the probability of the intersection of having COVID and testing positive, and the probability of being COVID-free and testing positive. So, yun yung intersection mo. So, that is 0.05 multiplied by 0.98 and 0.95 multiplied by 0.05. So, what are those values equal to? So, that would be 0.049 and 0.0475. So, if we are to add those two values, it will be equal to 0.965. I mean 0.0965. Okay, we now have these values. Kompleto na. The probability of getting a positive test result given that you have COVID, probability of getting COVID, and the probability of being positive. So, that would be, substitute the value of this one, that would be 0.98 multiplied by probability of Z, 0.05 all over the probability of getting a positive, 0.0965. And that would be equal to how much? Dito ko na lang ilagay. That would be equal to 0.5077 or 50.77%. This is the probability that a person has COVID given that he has a positive test result in the swab test. So again, a little disclaimer lang for this particular problem. I only assume these values. Okay? Wala tong basis for those values. I only use those values to demonstrate how can we use Bayes Theorem in real life mga situation. So I only assume those values. A little disclaimer lang. Okay? That ends my lecture 3 for engineering data analysis. And thank you for listening, and I hope to see you again in my next videos. Thank you so much. Salamat. Paalam.